And anyway, same information has been represented in a pictorial format. Say altogether robot sensors, they have been grouped into internal state type, used for robo control, because okay, that has been used to detect the arm position, velocity and acceleration. So the sensors that are all trying to detect the position, velocity and acceleration, they are all being referred under internal state type. Then coming to the external state type, these are basically used to guide the robot as well as for objects identification and also for objects handling. Under this, you have got non-contact type and contact type. Then coming to the non-contact type and contact type, under non-contact type, we are going to get proximity sensors, range sensors, range and vision sensors. Okay. Then under contact type, we are going to get touch sensors, slip sensors, and force and torque sensors. The information being recorded in this particular plot is actually correct. Maybe some deviation I have noticed in the last before slide that I have to correct. Maybe in the slide number 9, some information being represented over there is not observed to be good, but the information whatever has been reported here in the slide number 11 is okay. Now what purposes that are going to be served by range and vision? These two sensors are going to provide overall guidance for the robot. And coming to the proximity sensors and touch sensors that are all trying to deal with the last stages of object grasping. Object you wanted to grasp, before that has been grasped, we are going to sense that. And that particular sensing is being done with the support of proximity sensors and touch sensors. And coming to the slip sensors and force or torque type sensors, they are trying to provide the feedback for post grasping as well as for manipulator control. Say for example, I am trying to handle this. If I press more, the object is getting pressed. This is actually being expandable type. It is not going to create any problem. But with the support of touch and rather force and torque sensors being attached onto that, we will be able to see what the volume of quantity of force that has been applied to this. That we can see. Maybe if you feel that that force being applied is more, then we can draw a conclusion to say that that can be brought down. That can be reduced. Okay. That entire information we showed in the slide numbers 10 and 11 have been grouped together and that have been kept in the single slide. I'm sorry. Let us move to the position sensors. Let us move to the position sensors. Position and velocity sensors are used as feedback devices in robots. So it is something like, suppose you have given an instruction to move the robot. That instruction will go to all joints. So when it has been instructed to move, I'm sorry, I'll be talking about this particular slide. I'll move a bit and come. Okay. So when you have given an instruction to move your robot in the car, that movement is going to be happening, or that is going to take place at all joints which are associated to that particular robot in the car. There may be 2 joints, or there may be 3 joints, or there may be 4 joints, whatever it is, irrespective of the types of joints. because you will be, with the support of sensors, you will be able to know the initial location of them and the final location of them. And as per your knowledge, you are going to give the instructions to travel with certain velocity, okay. So with that velocity it would be moving, and that time your sensors are again going to sense. So it is something like this. You would have given some input signal and it is time to do something, and that doing is what you should know, that is going to be set through our sensors being attached to that, and it senses all that information and it sends as a feedback signal to us, and that signal at the other detector location, the input and output, both the things are going to be compared. So that is a corrective action that has been taken in order to ensure that the robo whatever we are using have been instructed to follow our instruction to the maximum possible extent. Then these are basically used to measure linear and rotary displacements. Position sensors, say x1, y1, z1 at one instance, x2, y2, z2 at the other instance, the shortest possible distance between them, if you try to refer, that is nothing but the line joining, that if you do, the movement is going to be linear. And x1, y1, z1 and x2, y2, z2, that might be possible for us to achieve only through rotational movements. Even that is possible to measure. With what angle that has been displaced is going to come as an output, as a feedback. That feedback is going to be compared with the input, and that is how the error signal is going to be generated wherever required. These are majorly used to control the position of the arm. That is obvious. Once you know these values, you are going to compare them with the input values, and that is how you are going to, control its position. Like that feedback is going to be used to move further. That way you can vary. Potentiometers, resolvers, and encoders are commonly used as position sensors. Potentiometers are not new for you. That uses Wheatstone bridge. You have already come across this in your earlier or rather pre-engineering course. Would be at your intermediate, or it would be even at it would have come to you even at 10th class or so. Resolvers and encoders are these three are some of the sensors that have been used to measure the positions. Now let us move to the potentiometer. I'm sorry. Any disturbance? I'm sorry, somebody has unmuted his mic and he is trying to make all of us to listen to the crow. He might be he might be taking care of a crow. That crow interactions he is trying to show, make us to listen by all of us. Anyway, potentiometer, when it tries to, potentiometers provide the most straightforward form of position sensing. That you can see here. This is linear, this is rotary, dimmerstat or variac. Based on the contact position you are trying to maintain, the resistance is going to vary. So resistance and length of that particular one are directly proportional. That has been taken into account. That relation has been taken into account. So it could be a linear one, variac, okay, rheostat. It could even be a dimmerstat. One will be having a rotary switch, another one will be having a linear switch. You can vary literally on that resistor. They produce output voltage proportional to the position of the wiper. This is what is actually the wiper in this case. That wiper will be maintaining contact. See here, one end of this has been connected, other end is actually being connected through the wiper. Even here it is actually happening like that only. It was not showed. See, this is the end being connected to one end, one terminal. This is being connected to the other terminal. This is actually trying to give you the output voltage. Okay, so here these two differences are going to give you the output voltage. The figure illustrates a typical pot in the sense potentiometer. First three words, first three characters of a potentiometer is actually pot that has been. Potentiometer may be linear or angular. Okay, potentiometer can be linear or angular. You can put in your own words. Say this entire thing is a resistor. Total resistance is actually R. This end is actually being connected to one end, maybe power source. Then the wiper can be moved from this location to this location. Maybe here it has been showed as A. The other end you can label it as A dash or B. From B to A, the wiper can be made rotated. If it is at B location, the power is being shot. When you go on moving the wiper, the total resistance is actually this. You are trying to reduce the resistance. Accordingly, the output voltage is going to vary. Same is happening even in this. So likewise, you may kindly put it in your own words. So this is your encoder. This is your encoder. Maybe if you try to see this particular encoder, this encoder anyway, it has got a circular disc having some slots, transparent slots alternately. That too, they are all equally distributed. Now in this particular figure, this vertical rectangular piece, if you refer, that is your piece of this. So this piece is this. And you have got a light emitting source here, and you have got a photo detector. So now this particular disc is mounted on this shaft. When this shaft has been rotated, the disc also rotates. When this disc rotates, and when the light has been made to pass over through this disc, there are alternately slots. Whenever the transparent portion comes, that light source travels. Then whenever the obstruction comes to the light source, that will not travel. So whenever the light source has traveled through the slot that reaches the photo detector, it catches up that as an input. Then that information is going to be amplified, and that is going to be sent to the counter. Same information has been stated here. The encoder is a sensor attached to a rotating object such as a wheel or motor to measure rotation. Encoders are used to measure displacement, velocity, acceleration, or the angle of a rotating sensor. An incremental encoder consists of a disc marked with alternating transparent and opaque strips aligned radially. So this is what is of that particular way. Maybe you are going to come across two types: incremental encoder and absolute encoder. Okay, that entire procedure has been listed. Photo transmitter is located on one side of the disc, and a photo receiver detector is on the other side. Light beam, output shaft. In order to find the direction of rotation, two sets of photo transmitters and photo receivers are placed at 90 degrees out of phase. See, Maybe with this straight configuration, we may not be in a position to know the direction of rotation. In order to know the direction of rotation, photo receivers are two sets of photo receivers are placed at 90 degrees out of phase. Okay, so the idea is, say suppose you have a slot and you have a photo detector here. Now followed by you have got a non-open slot, means obstruction is there. Now this is one set. Another set is going to be offsetted by 90 degrees such that even if this one rotates, disc rotates, when one time through one set, that photo beam is going to be made to pass through. Simultaneously in the other set, photo beam is not going to be passed through. So that way they have been accommodated. That way you try to imagine. In order to take the accountability of direction of its rotation. And of course, the absolute encoder, if you try to consider, it is not going to bother about the starting position. So the basic difference between the absolute encoder and the incremental encoder is, incremental encoder takes into account the starting position. Absolute encoder doesn't bother about the starting position. Okay. So the working construction and working procedure is same for both the types. More number of strips corresponding to the number of receivers and transmitters are found in this. That kind of figure has been shown in the next slide. See here, these are all the slots, transparent slots. Earlier thing was actually showing only one radial slot, and those such slots were distributed radially. That is what is the kind of sketch what we have seen. You can see here in a radial direction itself, in this figure there are 5 slots, means 5 light sources are there, means 5 receivers are also there. Okay, so this particular disc is going to have so many slots like that. Okay, now you can see here many more. Why that has been kept like this? See here, let us see this, how it has been done. This has been labeled as 2 power 1, 2. Then the next one, okay, 2 power 2. The next one, 2 power 3. The next one, 2 power 4. Likewise, slots being arranged in a particular periphery, based on that you have gone. And based on this number, only the angle precision we are able to. 360 degrees divided by x. What is this x? Range. That range, if you key in over here, 360 degrees divided by range, if you key in, that is going to give you the angle of precision. Okay. Anyway, so when you try to see at the receiver end, there are going to be inputs either in on mode or in off mode. Okay, on mode in the sense 1, off mode in the sense 0. Position sensor encoder with the support of optical shaft. See, you have got a DC motor, you have got gearing. This is your robo joints, arms. So based on the movement of the arm, that is going to move this particular gearing, that is going to move this particular DC motor, and that is going to give an input to the optical encoder. You can see even here slots are there. You have got emitting diode, you have got what you call sensor, and that particular receiver will try to receive the signal like this, because whenever for this particular emitting source, whenever the slot is there, that time on means 1. Whenever the obstruction comes in between, that time off, that means 0. So this is for 0, this is for 1. Okay, so I think I need to stop at this end. I need to stop at this end. because we have already reached 11:46. I'm still stopping the share screen. I'm also stopping the record. Stop recording also I'm pressing.